Hello and welcome back to our online tutorials. Welcome back to our online tutorials. We continue with our kit 6. I believe we've talked about question number 10 in the previous video, where we were looking at multiples of equations, which we had exponential equations, logarithmic equations, and so forth. So today I want us to now focus more of the simultaneous equations involving exponential and logarithmic equations. Exponential and logarithmic equations. So I'm sure my screen is able to reflect some questions there. If you're not able to see clearly, I'm sure you can still refer to your worksheet 6 of question 11. So we'll start with the first one. The first one says we want to solve simultaneous equation, which is saying that solve log 2 x equal to y, and we have another one which says y is equal to the log of base 4 2x minus 1. So simultaneous equations are basically certain equations which always move in pairs. By pairs, I mean that they always move 2 by 2. So we want to find the variable x, and we also have to find the variable y as well. So we have to see what is the value of this x and what is the value of the other y. So when you have simultaneous equations like that, you have to strive by all means to use all the knowledge you know in mathematics, use all the properties you know exponentially and also in logarithmic way, so that you can try by all means to make sure that both variables are found. So now, I believe the easiest way in this case you can be using is basically using the substitution method. Be able to make maybe x or y in the first equation, substitute it in the second equation. So this substitution method will always work best by basically analyzing which of these two is easy to make the subject for. So now if you look at the first one, this is our first equation. So we are going to simply say that using equation 1, so if I'm using equation 1, what is going to happen basically here is that I'm going to have the log of 2x equal to y. So log 2x equal to y, making x the subject, this is just basically 2 power y equals to x. Change from log to exponential form. So that is the easiest for now, because I'm going to have an exponential form. So once I make x a subject here, we are going to replace this. We can now replace in equation 2. So if I replace in equation 2, everywhere where there is x, it will be now 2 power y. So that we can have y to be equal to the log of base 4, open brackets, 2, open brackets, 2 power y, closed, minus 1. Something like this. So where there is x now, it is being represented by 2 power y. Why was I making this to be like this? Why was I doing it in this manner? So that I can be able to have the same variable. So it is easy to work with one variable first. So I've used substitution method. I've used equation 1 to substitute something in equation 2. So in equation 2 I have x and y. Though it is very much possible to still work with y equals to this and substitute it there. But remember, these two will have different bases. It will still again require you to change it to something of the same base. So I think the easiest in this case will work with the making x the subject in the first equation and insert it in the second equation. So basically, there are a lot of ways of killing a rat. Whatever method you can use, as long as it's part of the rules and as long as it's part of the rules of mathematics, it's able to be applied and you're able to work with it. Now here we are now solving for y, just like we were doing in question 2. It is now one variable here. So if it is just one variable there, what do I do? Convert this to exponential form. This is the output, this is the base. So this is just equivalent to 4 power y is equal to the input, which is 2 power y minus 1. Yeah, okay? So if that is happening, so now this kind of equation which is being formed, if you have bigger eyes, you should be able to see that this is something in the form of a quadratic form. Remember, everything can come to this side. I can have 4 power y minus 2 power y minus 1 is equal to 0. So if that is achieved, this 4 power y can be written in a special way such that according to exponential properties, the 4 can be broken down to 2. But outside here I have the y minus 2 y minus 1 is equal to 0. This is what we have. So that if we now rearrange this in a simple version, what am I going to have? I'm now going to have something like, remember these 2y and y are powers. Simplified, they can be multiplied by making it to be 2y. So I want whatsoever is here to be visible to be the same as this. I can just swap this, let the 2 go outside and let y come inside. Basically it's still the same thing. 2 times y is the same as y times 2. So if I start with the y, basically there is no harm which is happening. So this guy can be written as 2y and the square and outside. I've just interchanged. 2 times y is the same as y times 2 minus 2 squared minus 1 is equal to 0. This is what I'm going to have. And then there now, we are now going to solve that as a quadratic. Now, this is something which is a little bit complex again. So to make it a little bit simple, what do I do? Let's 2 power y be any letter of our choice, say z. So I'm going to use z everywhere where there is 2 power y. So 2 power y will be z. I'm going to raise it to squared minus 2 y squared is what? Wait a minute. This is 2 power y. Remember, it is coming from here, 2 power y. So 2 power y, which is 2z minus 1 equal to 0. Solve this as a quadratic equation. So solving that as a quadratic equation, 2 numbers which can be multiplied, they will give us a what? A negative 1. So let's go back. This negative 1. This was negative 1 which came from here. Remember, this was 2 power y minus 1. Everything came this side. This became negative 2 power y. This crossed and became, actually this is supposed to be positive. Let's make that correction. Because this is 2 power y. When it crossed, it becomes negative. This is negative 1. When it crossed, it becomes positive. So this is positive, and this is positive. 2 numbers, when you multiply, you have positive 1, but when you add them, you have negative 2. Negative 1 and negative 1. So this is just basically z squared minus z plus 1 is equal to 0. So if that is achieved, we can factor out by pairs z, open bracket z minus 1, negative 1, open bracket z minus 1 is equal to 0. So that we can have z minus 1 is equal to what? Is equal to 0. Am I correct? Yeah. So if z minus 1 is equal to 0, this implies that z minus 1 equal to 0 and the value of z is equal to what? A 1. So now since the value of z is 1, recall that this z was what? 2 power y. So we're simply saying 2 power y is equal to 1. So if 2 power y is equal to 1, this implies that 2 power y is the same as 2 power 0, because any number power 0 is this one. So if I have 2 power y equal to 2 power 0, this is equivalent to y is equal to a 0. This is what I'm going to have. So if y is equal to 0, we found the first variable, which is y equal to 0. Now, since we have found the first variable, y equal to 0, let's find the second variable. So you can use any of the two equations to find for x. So let me delete this part. Since we now have y, let's find x. So using any of the two, so if I use the first one, I have log 2x equal to y. Y is 0. What is your x? Log 2x equal to 0. This implies that 2 power 0 should be equal to x. And this implies that x is equal to 1, because the 2 power 0 is what? Is 1. As simple as that. You have solved your simultaneous equation. That is the question 11a. Now let's go to the second part, which is the B part. So the B part says, solve. We have log 4x plus y to be equal to 0, and we have log 4 y plus 1 is minus, it's minus here, 2 log 4x to be equal to 0. This is what we have there. So as usual, let's use substitution method. So we use one equation to find a certain substitution to give the other one. So the easiest, as usual, I think it's the first one. So from equation 1, what can I make? I know that from log 4x plus y equal to 0, this means that x plus y is equal to 4 power 0. And this 4 power 0 can be written as what? X plus y is equal to what? To 1. This is what we have. Meaning that we can make one variable the subject and go replace in the other. So let's say y the subject. This means that y will be equal to 1 minus x. So this guy can be replaced in equation 2. So if we everywhere there is y, we put 1 minus x. What am I going to have in equation 2? I'm now going to have log 4 open brackets y plus 1. Instead of y, I'm going to put 1 minus x plus 1 close minus 2 log 4x is equal to what? 0. We are okay? And then from there, we can do the usual thing. This will be 1 plus 1, which is a 2. I'm going to have the log of 4 open brackets 2 minus x minus 2 log 4x is equal to 0. We can simplify this as one log from the properties. This is log 4, this is log 4. This can go pamwamba and becomes log 4. The numerator will be 2 minus x over the denominator when this crosses becomes x squared. This will be in the input. And the whole lot of this is equal to what? Is equal to 0. So now let's find the value of x. Convert this to exponential form. This becomes 4 power 0 is equal to 2 minus x over x squared. We are okay? So that we can have we are going to have 4 power 0 is basically just 1 to be equal to 2 minus x over x squared. When I cross multiply there, I'm going to have x squared to be equal to 2 minus x, and then since it will be quadratic, everything comes to the other side, becomes x squared plus x minus 2 to be equal to 0. To be something like that. We are okay? So now, we're now going to solve it as a quadratic equation. Let me erase this part. Let me erase this part. We're now solving for x using that equation. So we have x squared plus x minus 2 to be equal to 0. So do I have a situation where I have two numbers which can give me -2 when multiplied, but +1 when added? The two numbers basically will be -1 and 2. So x squared minus x plus 2x minus 2 should be equal to 0. So x, open bracket, x minus 1, 2, which is +2, open bracket, x minus 1 should be equal to 0. X minus 1, x plus 2 should give equal to 0, implying that x minus 1 is equal to 0 and x plus 2 is equal to 0. So this becomes x is equal to +1 and x is equal to -2. So if you have two values of x, it implies that you need to have two values of y. So if x is 1, what would be y? You can use maybe the first equation if you wish to. So if x is 1, mean that log 4, open bracket, upper the x will put 1, plus y should be equal to 0, implying that what? 4 power 0, which is 1, should be equal to 1 plus y. With this one comes to the other side, becomes 1 minus 1 equal to y, so that y can be equal to 0. So this means that if x is equal to 1, the value of y is equal to 0. What about if x is equal to -2? I'm going to have the log of 4, open bracket, -2 plus y should be equal to 0. 4 power 0, which is a 1, should be equal to -2 plus y. This one across the other side becomes 1 plus 2 should be equal to y. And the value of y becomes what? Becomes your 3. So when x is -2, the value of y is 3. When x is 1, the value of y is 0. You've solved that simultaneous equation. We are okay? So basically, all the equations, that's how they are. So those that was A, that was B. The same is happening with C and D. With C and D. Just basically use one to substitute in the R. Use one to substitute in the R. And it will be very much simple. So, which one can I work with? I can work with C, and then I believe D can be yours. You can also refer to the document. I'm sure that those questions were solved in the document. So, let's look at C. Can give hints on C. So C says, if we have 3 log y to be equal to log 3 plus log x, that's the first equation. And the other equation is 3 power y is equal to 9 power x. That is another equation. So use one equation to find another. So what can happen there? Obviously, the simplest to use is equation 2. Using equation 2, so using equation 2, I have 3 power y to be equals to 9 power x. This can be written as 3 power y to be equals to 3 power 2x. Am I correct? Yes. 3 squared is 9. So broken down this 3 to be power 2. So if they have the same bases, it means that 2x is equal to what? Y. This is what we have. So if we have 2x equal to y, if we can replace this guy, so this can be replaced in our first equation. We used the second equation. So what we are going to have, we'll replace it in the first equation. So it means that everywhere where there is y, we are going to put 2x. So if the second equation has 3 log y, instead of me using log y, I'm going to use 2x equals to log 3 plus root of, oh sorry, this is not a root, this is just log x. Log x. Like that. So that let's now simplify things. So in our simplification, what can happen there? Let's take everything which has a variable on one side. This one has x, this one has x. This is the same as these 3 can go on top. This is going to be log of 2x power 3. When this one comes inside, it will be minus log x is equals to log 3. I've used everything which has a variable. So that from the division principle, this becomes log 2x power 3 over x is equal to the log of 3. This is x power 3, which would divide with 1 to have x squared. I'm sure in the input here we're supposed to have something like log. This power 3 is for 2 and the x. So we're going to have 8, because 2 power 3 is 8. X power 3 is 3, but 1 cancels out with this. We're going to have x squared for this one. Should be equal to the log of 3. We are okay? We are okay? Yeah, so from there now, it is up to you. Say any method which you can use should be basically should work out. Any property you can use. So now we're now with this guy here. This is what we have here. So it is up to you number to do whatsoever you can to make sure that the value of x is visible. So what you can do is, for the fact that we know that this is a log and this is a log, there is an equal to sign here. This is the input and this is the input. The same log here. So if we have the same log and some different inputs, but there is an equal to sign in between, this means that this, for this to be equal to this, it means that the inputs should be the what? The same. So from that property, this is a log, this is a log, and there is an equal to sign here. For equal to means this, whatsoever is this side is equal to this. So it means that 8x squared should be equal to 3 for this equal to sign to be obeyed. So we use that principle there to say, for this to be obeyed, 8x squared should be equal to what? To be a 3. Want to find the value of x over 8 over 8. This goes, and x squared will be equals to 3 over 8. Square root, square root. This goes, and the value of x becomes what? The root of 3 over 8. That's the value of x. The root of 3 over 8. So others will simply say, when you square something, you raise a positive or what? Or negative, the root of 8. So if you have this as your value of x, you are able now to find the value of what? The value of y. Use any of the two to find the value of y. So basically, what am I going to have? I'm not going to have, which one is the easiest to work out with? This guy. I know that 2x is equal to y. So if x is equal to the root, it is 2 multiplied by the root of 3 over 8 to be equal to y. So this is the value of non-can y. So basically you can use those simplification to find the value of x and the value of y. You know you have calculators, so you can even use your calculator to simplify your values like that. So that is your C. I'll leave D for you. Send the solution for D. I'm sure some of you will just copy and paste from the document, obviously, because I sent these solutions in the document. This is just something to help you follow through in case of maybe a stack from the document. So you can be able to solve D and be able to send through. Thank you very much, and we'll have the next video. See you in the next video. Obviously, we'll be talking about the application or maybe graphing of these functions. See you, and blessed evening, day or night.